Cool. Thanks for bearing with me, everyone. So yeah, very happy to be here presenting for you. Thank you, Madusha and Google for having me here. I guess show of hands to start off. Who has heard of LangChain before?
Who has heard of LangChain?
Sorry, is my audio not so good?
Your audio is good.
Sorry?
Your audio is good. We just kind of...
Okay. So it looks like a few folks. Maybe you've seen us around, haven't tried us out, but before I get too far into things, I'll be talking a bit today about a topic called Retrieval Augmented Generation, which we'll get into a little later, where you're essentially guiding LLMs and LLM outputs with data from external sources. And yeah, bit about LangChain. We make it easy to build context-aware reasoning applications, specifically with large language models. And I understand many of you are students and new to generative AI. The general idea is these models are very powerful, but are even more powerful when you do things like chain calls together, bring in other sources of data, work in other ancillary pieces like vector stores, like document loaders, and other pieces like that. And the way we think about it, we think of it as a kind of 4-layer cake. And kind of the foundation piece here is our open source library. So that contains that's LangChain.com. GitHub. LangChain's GitHub repo for Python and JS, which includes things like document loaders for loading data from different sources, transformers for formatting, vector stores for things like similarity search, various pieces like around prompting and models themselves, of course. Then also next, pieces that make chaining things together easier. So we have our own syntax called expression language, and some use cases there are retrieval augmented generation, which we'll get into, querying SQL databases via LLM. So you can do cool things like give an existing SQL database some schema, have the LLM generate a query and like pull out results that way. And then chatbots, which I'm sure you're all familiar with, very hot use case at the moment. To support all that, we have a platform piece, which is Langsmith, our observability platform, and evaluation as well. So you can sort of see how things are doing in production, have users give feedback, and like filter good and bad runs out and create data sets for further fine tuning, things like that. As well as a prompt hub for sharing and uploading and using prompts. And finally, at the top here, we have various use cases that we show. So things like chat LangChain, web LangChain, we'll get into a little bit. These are chatbots over LangChain's documentation, show off sort of the power there, and web LangChain, a web researcher. And the newest piece here is actually a new thing called LangServe, which assists with like getting products that you build with and chains that you build with LangChain into production. I'll get into that at the very end. So on to the show. Retrieval augmented generation. That's what long form of RAG. As I said earlier, it's a way to essentially get the guide the LLM's generation using data from external sources. So I think this vaguely, if you're trying to answer a question generally, whether that's let's say how's the weather or what's the weather like in Waterloo. On one end of the spectrum, you have retrieval only, which is where you have predetermined sources or documents, and you just know, or you have some engine or something like that basically you would type in what is the weather like in Waterloo, and it would bring you back some documents, and you have to read through them, and there could be many, but it's manual work there. Then on the other end, you have generation only. So using something like Palm or GPT-4 3.5, that's where you ask the LLM, what's the weather like in Waterloo? And unfortunately, LLMs aren't trained on the most up-to-date data. They can't pull in external sources natively, so you get something out of date or otherwise unsatisfactory for like current events. And what retrieval augmented generation attempts to do is add some of the task-related documents to the LLM as context as part of the prompt from things like Google or from your, some examples could also be like spreadsheets or PDFs in your organization or you just have lying around, and using those as like context to guide the LLM's generation. So an example would be the general flow would be something like this, where you have these external data sources and you basically pass them to the LLM as this context and say, given this context, LLMs can't may think you're referring to different things if you just ask them straight up. So given this context, parse this information and generate some output. So that's the crux of it. And in practice, this works a bit like the slide here. As I mentioned, you load external data from sources like PDFs, databases, the web, into documents. And then because LLMs tend to, and actually, before I go too much further, just so I know how to guide this a bit more, how many of you have built something with generative AI before? Show of hands in the audience. Okay, cool. So it's a little bit small, but it looks like about a third of you. So I'll keep it a little more, a little bit higher level or lower level here. LLMs have something called a context window, which means you can't just put, for example, like a book into an LLM and expect it to perform effectively. Some providers, Anthropic, I think, is famously announced a 100,000 token context window, which is you can think of a token essentially as about analogous to a word. So you could upload a lot. Having said that, performance tends to great if you have too much text, and like the LLM will tend to get distracted and generate poorer outputs if you with less focused input. So an important second step here is to split the data that we have before passing it to the LLM into manageable size chunks, and only pass a subset of those chunks to the LLM at final generation to reduce this risk of distraction. And one common way to do that is have this ingest flow where we load it into a specialized database or specialized database called a vector store, using a process called embedding, where you take raw text data and create a machine searchable representation of that raw text data. And yeah, finally, on retrieval, we query this vector store for semantically similar chunks. So again, we take advantage of the way we've chunked and stored this data to only retrieve data that's relevant to our input as best we can. And finally, with this output step, we pass everything to the LLM and generate a final answer based on the input question and then any retrieved context you might have from our external data sources. And as a reminder, that's PDFs, databases, the internet. Generally, could be it's pretty broad. So yeah, some examples of this. Chat LangChain, which I mentioned earlier, it's a chat over LangChain's Python documentation. So you can ask questions about how to use our framework, and you can check that out at chat.langchain.com afterwards. And that's using a documentation website as our input sources and data. And another one is our web researcher example, which is Web LangChain, creatively named. That uses sources like Google Search and a few others like TOTV, and we actually have some examples with SEC filings and things like that. You can try that out as well, but taking the internet as a data source and chunking it on the fly, and I'll show how that works later. Cool. Let me pause actually. Does anyone have any questions at the moment, or should I reiterate anything there? Yes.
Can you go back to the document example? So let's say you have a bunch of documents in storage. What kind of queries, what can you do with them? What's practical?
I'm sorry, can you repeat that?
Yeah, so in your previous diagram, you have this notion of connect a bunch of documents, like PDFs, your page. The next slide. Sorry, next slide. So, and then you split it somehow, you put it in the vector store, then there's queries. So let's say we have a bunch of documents, design documents, right? What kind of queries would you do against them? Let's say you have a large corporation, you're doing hundreds of thousands of design documents. What would you do with it? What's a useful example?
Yeah, absolutely. I think generally why retrieval augmented generation has been such an exciting and popular use case for LLMs and really plays to their strengths in a lot of ways is the fact that they can, if you have hundreds of thousands or even thousands of pages of documents and data, it's been kind of an unsolved problem for, and you can look at tools like Notion or I guess not as familiar with like maybe what specific folks are using it with Google, but I'm sure Google has great tools. I think Looker maybe is another one with Google Cloud, but you can essentially solve this problem of taking all this unstructured, difficult to search through data and like make it available as to other folks in your organization or people who want to like search through all that data very quickly and get relevant results from them. So I think using SEC filings is a great example. Companies have to file certain data with the excuse me, I forgot I'm speaking to Canadians here. The American government, the SEC is a like financial regulatory board for American corporations, and American corporations have to essentially file like reports to the governing body containing lots of relevant information about like competitors and mergers, things like that when things go. So there's just a ton of data. It tends to get blocked out. So you could ask, for example, like what are some relevant mergers that happened in the past year, and it could pull up lists there, like specific companies, like who are Etsy's main competitors, or like what are their competitive risks. So these questions get rather a little bit more abstract as well, like and require a bit more reasoning, and that's kind of where the LLM shines as well. I hope that answers your question. I can go into more detail.
Thanks.
Sure. Okay, so moving along. So get into a bit more detail of how you'd implement something like this. I'll go over a kind of standard, really nice use case of LangChain, which is our kind of standard retrieval augmented generation chain, rather. It all starts with this ingestion pipeline that you see on screen here. It's roughly analogous to the first three steps here, where we're loading, splitting, and storing in a vector store. We take our original source, we split using some text splitter that can be context aware. So, for example, if you know that you're working with code and you want to add code to your vector store and search over a code base later, you can split your chunks based on things like class definitions, so that you're more likely to get an entire class definition within one chunk. So then you pass to the LLM later, you're more likely to have full context of what you want to generate with. Another example might be with, like PDFs. You're splitting on paragraph rather than like in the middle of a paragraph. So I think when we write papers, we tend to put split ideas and split context by paragraph. So making sure we split in such a way that we get as much context in a chunk as possible will give the LLM the best chance of getting the best results. So it's a bit of an art form there, but that's kind of the initial step with our retrieval chain. And from there, we, again, on retrieval, take an original question, pass the LLM, use that initial question to find similar chunks with similarity search on our vector store, pass that plus the chat history to the LLM, and then use all that information to generate an answer. So we're essentially taking various sources, passing to the LLM as context, and using all that context to give the LLM some guidance on what to generate. Cool. And there's another step in the notes here. If we want to think a very common one, things like ChatGPT, and people have been becoming more used to chat interfaces with these things. So it's not enough to maybe answer one question. Maybe we want to answer follow-up questions. So, for example, if I'm splitting a resume or asking a question about someone's resume, you might ask, who is this resume about? Like, what are their main qualifications? And then let's say the LLM's output doesn't include some kind of reference to JavaScript. So you might ask then, do they know JS? Do they know JavaScript? So this is actually a little bit trickier than it looks to handle, because the way similarity search with these vector stores work, with these specialized vector DB, they require, you're basically looking for keywords and like semantically similar search terms within your source document chunks. So if you have something like a pronoun or other reference with they, you're going to get results that match they instead of match, for example, Jacob or Madusha, which again is not, will get you worse quality chunks, and then the LLM will get a bunch of, when you pass something to the LLM at the end, you're going to get information that isn't relevant to what you're actually asking. So kind of a common optimization you can make here is adding a additional step to the LLM where you essentially take this initial input question, do they know JS? And you pass to the LLM as a first step to what's called a standalone question, where we've dereferenced all references such as they with context from the chat history as well. So this initial do they Node.js question will get dereferenced to does Jacob Node.js, and then you can pass to the vector store. It'll you have some intuition of who Jacob is based on the chunks, and you'll get chunks relative to Jacob, get better results that way. And I'd like to pause again. I know this is a lot of information, so if there are any quick questions, I can answer them now. Okay, excellent. So yeah, a lot of high-level pieces here. To get a little bit more concrete, we'd love to dig into. I'm glossing over a few things with the LLM here. So I'd love to kind of zoom in and go over a few pieces of like implementation details around this. So zooming in here, when I say LLM, I really mean a kind of collaboration of a few different pieces. So I think a lot of the best models out today, GPT-4, Palm 2, are usually interactable and better suited for applications where you're chatting over data as chat models. There's a split between sort of like text completion, predictive models. That was the original GPT-3, and then chat models such as like Palm 2, Claude 2, and GPT-4, Chat GPT, etc. So these chat models, again, Vertex has Palm, which being it's a Google event, I'm sure is popular with many of you. And we also pass in a prompt. And the prompting here, I'm sure you're all familiar with prompting if you used ChatGPT before, but prompting definitely has some. While LLMs are extremely powerful, prompting requires some skill and technique to get good results. You can't just directly ask certain questions. You may, or at least there are ways you can improve the results you get based on such prompting. So to show this, I'll go into a bit of detail about some of the web research the web researcher we built, and show some of the tips and tricks that kind of made this more effective. And you can see it here. It's available in the LangChain prompt hub here. I won't read the whole thing, but essentially it starts with you are an expert researcher and writer, tasked with answering any questions, generate a comprehensive, informative, concise summary, etc. And then you can see it has a input section for context where we'll pass in the retrieved chunks that we've gotten from the vector store or LLM, data source. And you'll see there's also some additional sentences on generating citations and inserting those in the text for the final results. So a few pieces to highlight here that I think folks find interesting and useful. One is the first sentence, actually. You are an expert researcher and writer. So this seems like, why are we telling the LLM what to do? This seems maybe a bit unnecessary or superfluous, but I don't have it sounds a bit silly to say this, but LLMs are, this actually significantly helps generation in many cases, especially with specific knowledge. And I think the best way to intuitively think about this is that LLMs are trained on essentially the sum of all human knowledge, or as many as OpenAI, Google, Anthropic can get their hands on. And this is billions of tokens and equally valid as a input question, and one that if you've asked ChatGPT before or used ChatGPT before, you can say something like, you know nothing about English, and that's an equally valid query as, do a good job responding to this. So given that the LLM has the entire range of all human knowledge, including perhaps, YouTube comments or certain, in addition to the works of Shakespeare, where we don't want maybe the English isn't proper or something like that. The LLM has to kind of sift through and parse out what bits of that knowledge it wants to use to predict the next token. So telling it that it's an expert in a certain field actually clues it in intuitively, and narrows the scope of knowledge that you're querying with to only perhaps like the good stuff like Shakespeare or archive papers, etc. So sort of very simple tip, shocking improvement, I'd say. Another interesting emergent behavior here was using bullet points for readability, specifically for citations. So with LangChain, one of the nice pieces, has anyone here used Perplexity before or heard of Perplexity? Me show of hands. 3 people, okay. So not too many, but essentially one important thing with, or one common, I guess, request or ask with retrieval augmented generation pieces is that they, okay, I guess also hallucination is kind of a commonly used term with this, but LLMs have a tendency or may make up information or pull up information from sources that you don't necessarily want them to. So a good way to give and build confidence in LLM outputs, especially with retrieval augmented generation, is to ask it to cite its sources or show where it's getting its information from. So to do that with LangChain, we ask it to cite its sources, and I think we had pretty mixed results initially, but actually telling it to use bullet points for readability made it gave it the tendency to cite each bullet point for the citation. Before, it would kind of tend to throw them all at the end, or it would tend to leave some out or spread them out. Sort of, it wouldn't do a very good job of spreading them out. But telling it to add bullet points seemed to really give it improve the citation quality. So also it has the advantage of making it more readable. I'm sure you've all seen, as an AI language model, things like that in various generations, and asking for bullet points can have it focus in on individual facets of the response more easily. And yeah, final piece here is this kind of interesting context block here, where we're actually injecting the fetch chunks. So something's call out. You can see that we have a funny context bracket, like brace, context, brace. If you're familiar with HTML, I'm sure many of you are. This will look pretty familiar, comparable to like a div tag. And this is kind of an interesting piece. I think many developers are used to using things like JSON, and I don't know, maybe if you've looked at prompts like this before, you may have seen like long dashes and lines that try to denote like what parts of the prompt and passed in parameters are actually context versus not. And I think it's been a bit of a what we found works really well is, for many models at least, because they're partially trained on code, it actually does a pretty good job of parsing XML and drawing delineation between based on like these tags. So you may find, like we found this to be more effective and gets the LLM in the right quote unquote mindset to parse out specific pieces better, and could be something that you'd find helpful as well. So that's the prompt. And then finally, we have a output parser. So chat models tend to generate chat messages in response. So a kind of plumbing piece that we have at the end of it is a output parser that essentially takes these chat messages and reformats them into raw string. Our retrieval vector store will take requires a string as format. So this is we need to aggregate it as a string basically. So parse the output into the right format for the next step in the chain, essentially. Cool. So that's the LLM piece, and I hope that was helpful. I can pause again, and if anyone has questions about the prompting or kind of LLMs, happy to answer those questions now. Okay, you all pick stuff up. You guys pick up stuff quick. Great. So one more piece with specifically web research here I'd like to go back to is the ingestion pipeline. So if you have predefined data, so for example, PDFs or like SEC filings, you can split them into raw chunks, embed them into VectorDB, as I said, and then present those chunks to the LLM, and the rest of the retrieval chain is the similarity search from your predefined VectorDB. This becomes a little bit more challenging with a web researcher because you now don't have a predefined set of data. You don't have PDFs that you just want to specifically talk over. You instead have the entire internet. And this required a little bit of a tweak to the general kind of like quote unquote ingestion flow for the LLM or for the retrieval chain, where you can't really perform similarity search in the same, or you can as an API, but then the chunks that you'll get back directly from a web API or like a retrieval search API tend to be too large for the LLM and too distracting. So you can imagine if you're just going to Google and type in large language models, you get a bunch of results, which if you read are quality, but you wouldn't want to pass the entire thing in. They might contain things like ads or semantic information on the page, like toolbars, and getting that information into the LLM will distract it and ultimately reduce final generation quality. So we define a new on-the-fly pipeline that you can think of. So I guess ingestion doesn't have to be just vector stores and kind of simple retrieval and chunking over them, but you can do this on the fly where we keep this same initial step where we take our fetch sources from web pages or essentially web pages, split them into chunks as they're retrieved. So you still have the source chunks, and then rather than embedding them into a vector DB, we compute the similarity. We compute a similarity matrix on the fly, where we take incoming chunks and then we compare them to the query that we want to search over, and compute them on the fly, and essentially rank the chunks based on that. So we take those ranked chunks now, pass perhaps like I believe in practice we're using the top 20, pass the top 20 to the retrieval chain, and effectively recreate our vector DB predefined flow with just on the fly tooling. So yeah, and again, you could cache data in a vector store if you want for this, but the internet's constantly changing and data will often go stale. So if you ask, for example, what's the weather in SF or what's the weather in Waterloo, that will change on a perhaps hour-to-hour basis. And if you were to cache things, you might get bad results. But and there tends to be not too much cost to searches tend to be pretty varied. So caching has certain trade-offs and complications with expiring data that it's just simpler to kind of compute this on the fly from fresh data. So yeah, that's kind of the RAG flow here. Any questions about that before I continue? Cool. Okay. So there's one more piece here that we think about, and that's deploying a chain like this. So it's all well and good to have it running in a Jupyter notebook or something that you can just run on as a script on your laptop, but making this available and like accessible to others over web context has certain complications as well. I'm sure many of you are familiar with kind of how ChatGPT will stream output back at you, so it won't just like blast the entire response at once. It'll sort of letter by letter create some kind of response message. And turns out things like that are a little bit harder than they look. So one thing we've been thinking about a lot with LangChain is how to make these things available and make chains that you create that do really cool things, how you deploy them to production, essentially. So yeah, how you take an initial chain and convert it into a set of endpoints. And that's your tooling for it. And some other considerations here, stream back sources as well. So getting, given some, you don't necessarily just want to trust the LLM blindly with what it's responding with. You want to also show like where it's getting its information, site sources, etc., and make that more accessible. So, yeah, you can basically use LangSurf to take an initial chain, add it as a fast API route with various streaming endpoints and logging intermediate steps as well. So taking those kind of what the retriever returns and returning that to the client as well as things like invoke and batch that can be useful for other applications. But yeah, I'd love to kind of show everyone how it looks in action. And to do that, I will share my screen now. Let's see, share screen. And I think I've got it. Window, that's good.
Yeah, do you have any of those examples publicly available on your repo? Or
I'm sorry?
do you have any of those repos available publicly for?
Yes, and I'll get into it after the demo. This is I'm going to show off WebLangChain, which is our open source sort of web researcher. Can everyone see my screen, by the way?
Yes.
Okay, cool. Oh, whoa, okay. A little mirroring action going on. Cool, so this is actually live at weblangchain.vercel.app. And I've actually set it to use Google Vertex, the Palm 2 models via Google Vertex, which is the Google Enterprise offering. But I can switch to Claude or GPT 3.5 as well, and I'll kind of show some differences there. And I've also got several different sets of retrievers I can use. So the default one I've got here is a company called TOTV that is essentially the folks behind a popular open source project called GPT Researcher, which pioneered some of the kind of initial stabs at this sort of space. SEC filings, like I mentioned, SEC press releases, another sort of LLM-based search engine called U.com, and then Google itself using the Google Custom Search API. So what I can do here is ask any question I want. So I've got a couple defaults here, but I could also ask where is Waterloo. This will use Google Vertex AI and TOTV to pull in some sources. Give it a minute here. And it'll kind of go through that RAG flow I showed off before where, essentially, yeah. Okay, so I get, of course, a picture of Kitchener, which is cool. I've been to Waterloo, by the way, many years ago. Had a great time. And but I think the more popular and more famous one to Google is unfortunately where the Battle of Waterloo was fought at the time in the Netherlands, now in Belgium, marking the end of the 100 Days campaign. Yeah, I can see it. Tavili returned a few different sources here, and then yeah, you can see that it ultimately chose to use the Wikipedia as a source. Click Battle of Waterloo here. We'll get like United Kingdom of the Netherlands and Belgium, which is you can see was where it got its data from. And yeah, to show this off more, I'll show off. I believe I mentioned LangSmith a little bit earlier. It's our observability and tracing tool for debugging and like checking out these chains. So I can go in and actually see a public. You can actually clicking this button makes it public. It's not doesn't necessarily have to be, but for personal private applications. But you can sort of go in and see every single step that's going on with the retrieval chain I mentioned. So you can see it starts with a serializing the history, which there is no history. So there's actually a slight optimization I didn't mention, which is you can skip the standalone question step if there's no follow-up question, or sorry, if there's no chat history, because you know that you don't have to do that because there's no text to dereference. And then I can go in and see even like different chunks here. So I can see the exact chunks that Tavili returned from Wikipedia, and then I can see the kind of like final output of like what actually gets past the LM. You can see the prompt here. And then we've done a little trick where we format the parse chunks using like XML as well. And then the LM can kind of parse it. It says 8 here, and that's because again, we slice the chunks using we filter the chunks using our like similarity matrix, and we filter out chunks that don't match our input query. However, in that case, it can also many like you might get multiple relevant chunks from the same source. You actually would expect that. So we do some remapping of sources to chunks on the fly on the front end as well. And then our string output parser, like I said here at the end. So if I ask a follow-up question now, for example, is there a famous song about that place? I'm sure many of you are probably familiar with ABBA, but I would expect to see Waterloo. Yeah, so yes, ABBA's Waterloo is about the Battle of Waterloo, which is actually kind of wrong because it references the Battle of Waterloo, but isn't quite. Yeah. So anyway, I can see this trace here where you can see it actually does do this now initial rephrasing step where it takes is there a famous song about that place? And again, if I were to search, so I'm using Tavili, not Google, but if I were to search, is there a famous song about that place? I get like random Red Hot Chili Peppers and things that aren't relevant. But this initial rephrasing step, takes this, given this following conversation, a follow-up question, rephrase, and now I get, is there a famous song about Waterloo? Which, if I put into Google, I now get, the ABBA song is expected. And then it passes this to the retriever, and you see the output kind of as expect, and you can see a bunch of output here, and then kind of the chat history is passed in as well to help the LLM along. So some pretty cool stuff here, and to kind of show, I'm sure many of you have been inundated by, I think I heard at the end of Mike's talk right before this, which LLM should I use? Or what are some of the trade-offs between LLMs? Google Vertex versus Cloud versus ChatGPT. I think one thing I've noticed about it's a bit ad hoc for sure, but one thing I've noticed about Google specifically is these responses tend to be very terse and like sort of to the point, very factual and confident. Whereas if I were to go and try, for example, all right, sorry. If I were to try out, for example, GPT 5, I could ask, where is Waterloo? By the way, let's see. So I get the same sources, which I would, pretty much the same sources, just differently numbered. But you see GPT 3.5's answer is much longer and has more information about the Battle of Waterloo, whereas Vertex more or less just like says this is I guess gives some context of Waterloo, but it's much terser, and then it says yes, Sab is Waterloo is about this. So I could ask is cool. And I will see something, yeah. So I guess UG 3.5 says it references it correctly, and yeah, says has a bit more information about it. So yeah, you can sort of there are many other like different considerations to think about, including context size and token length and other things like that. But tone is one thing to think about as well. These are both using the exact same prompt, by the way. So if I were to go in here and show you, you'd see pretty much the same process using Chat OpenAI instead of Chat Vertex. And this last step here, it's the exact same prompt to both LLMs. Okay, so that's the demo. I'll stop sharing now and go back to my slides here. So yeah, debugging with LangSmith, it's very important, I think, to be able to, especially once, and part of the reason I think LangChain emerged to begin with was to sort of deal with the fact that LLMs are most powerful machine calls together and perhaps use multiple steps with the different LLMs, with other data sources, etc. Debugging deeper chains can be difficult with just the common log or kind of traditional tools there. So having this tracing tool and this kind of technique is very useful and helpful. One other piece I didn't mention here is you can actually go in and like rerun. Actually, let me show that off. Very cool. So, window again. Let's say, for example, I did notice that this Google result was a little bit maybe didn't reference Waterloo quite the way I mentioned, or like didn't get the fact that the song only references Waterloo, but you can actually go in and actually Vertex isn't supporting the sorry, excuse me. I'll try with Chat OpenAI then, but you can go to our playground and try different. We have Palm here. It's two different teams at Google, so it's a little bit tricky, but you can actually go in and like edit, tweak parameters. You can see what it was invoked with, and then try different prompts. So I can edit my system prompt to be you are a pirate. Answer questions like a pirate. Then try to rerun it directly in my browser, and then it'll sort of give a funny pirate answer without any context because I deleted all the context in the initial prompt. So this can be a nice trick to show a bit more about how to debug and sort of test things in prod. Cool. So yeah, if you're all interested in trying out LangSmith, let's see. Yeah, I think I uploaded a slide without the code, but the code is I'll put it in the chat here. Hopefully everyone can see this, but connect to the YouTube account. Let's try the live chat. Let me try that quickly. But I'll make all these slides available. So yeah, this is chatlangchain.com. Error occurred. Okay, well, I guess I won't be joining the chat, but I can present this again. One more time.
You can put the link on the private chat that you may have, and I can share it with you.
Okay, sure. Yeah, let's do that then. That's probably easier. So yeah, I can send you all a
So the private chat you and me have on.
So LangSmith is currently in a private beta, but you can use this code LangSmith Partner 2023 to get access and
Are you okay?
try out your stuff early. It's completely free. So yeah, at this time, I'd like to answer any questions folks might have. All the links to the various pieces that I've demoed are available. Will be available in the deck. Hopefully, Medusa makes that available, and as well as source code as well. So GitHub repos for everything and sort of instructions on how to set up.
Is it okay for us to share the public code?
Of course, yeah. We LangChain is entirely we open source is a huge part of our DNA. The entire repo is open source for a reason, and that's to make it kind of spread knowledge and share how to build some powerful apps quickly. So please share, please tweet whatever you'd like.
Any questions? Yeah, we got a few questions.
Yeah, one question. Does LangChain work with
the freely available models like how does that work?
I missed the last part of your question. I heard, does LangChain work with the 3 available models and something?
Sorry, with the freely available models like
Things like, for example, like Llama 2 and Mistral. That's like that run locally in our open source. Yeah, definitely. We love working with open source models. I can show you. There's a pretty long list of sort of supported. This shows up.
Also, Llama 2 is available through GCP.
Oh, cool. I actually didn't know that. I can't seem to share my tab again. Yeah, anyway, short answer, yes, there's like a million and one models available in like different wrappers. And yeah, we present one of the kind of big value props of LangChain is presenting like a common interface for all these different models and vector stores and different methods of retrieval. So you're swapping, as you saw with LangChain, swapping them out is pretty easy. And yeah, we have that as a core part of the platform.
Does it work well with Llama?
Actually, so I gave another talk at a internal Google Summit. If you follow me on Twitter at Hakubu, you'll see it a little farther down the timeline. But I did a version of this chain fully local, so entirely with local models. You don't even need Wi-Fi beyond loading the initial web app. But I actually use Mistral, which is one of the newer kind of like smaller models that seem to significantly noticeably better than Llama 2. But it's a way to like chat with your PDFs and use something called Olama, which is like a really neat desktop app for running open source models with GPU support as kind of the powerhouse there. Unfortunately, there's some tooling to run LLMs in the browser. LLMs are require multi gigabytes of space, so you're not going to want to download it for web apps. So kind of the crux of the talk, but we need a new browser API. Once you can see a feature where every MacBook, every Chromebook, whatever, has a LLM running locally and can perform powerful inference. And you may be periodically updated like any other piece of software. It'd be really incredible to make that available to web apps and things that can run in the browser. So yes, local models can do this too. I think your powerful hosted models are still ahead for now, and it's not like you can run Llama 70B, like the bigger Llama models or some of the more powerful open source models in your MacBook. But if you wanted to host it on, like I think some of the some more powerful models like hosted on things like Replicate or I guess Google Cloud now should be able to do this pretty well as well. Yep.
Jacob, thank you so much for doing this. We got to definitely get you back to do one of these days.
Yeah, love that.
Yeah. Again, so thank you so much. Let's give you my hand.
And again, like all the links are available here. So you can follow me on Twitter at Hakubu, or formerly X, I guess. LangChain AI, LangChain at LangChain AI, and then you can check out the web LangChain web research I showed off at the site there. On Vercel, it's an XJS app, and then the GitHub repo, source code for it there, right below. We have a LangServe actually the kind of playground that you can toggle different and try different endpoints for deployed chains, which I didn't show off yet. You can check it out there, and cut off. Oh yeah, that's pretty much it. Yeah. Thank you very much. I appreciate everyone's time. Thank you.